Hello ladies, welcome to my first video review. I'm doing this review because I feel like I went through the sodium potassium pump fairly fast, and I wanted to make sure that you have not only references out there, but hear me give you the explanation as well. I've posted on Haiku a link to an animation for you to watch, which has a quiz at the bottom, so I suggest you look at that so that you can practice that quiz as well. But I'm going to go through it myself here, and so you can hear it from me. What we have here is an image depicting the sodium potassium pump, which hopefully by now you know is a mode of active transport. And when we say active transport, we automatically know that ATP is involved and that we are working against the concentration gradient, meaning we're moving from low to high. Now, in this case here, we have a pump here. It is an enzyme. This enzyme will change shape, which allows for the movement of certain ions, specifically sodium and potassium, in and out of the cell. Now, what's interesting here is that this image, which we see as a cycle here, will move through so that we can move sodium from a low concentration. Sodium actually is a low concentration inside the cell, in the cytosol. There is a high concentration of sodium outside the cell. So it will be moving from an area of low concentration to an area of high concentration. That is against the concentration gradient. Potassium is the exact opposite. There is a high concentration of potassium ions inside the cell in the cytosol, and there is a low concentration of potassium outside the cell. Therefore, it also moves against the concentration gradient. Now, in order for this to happen, we need to have our enzyme, our sodium potassium pump here, and we must also have available ATP. ATP is what is going to allow this process to occur, and it is going to occur by way of donating its phosphate, one of its phosphates here. So you can see this is an ATP. We have an A and 3 phosphates here. It is going to break off one of these phosphates here, which we should note is through hydrolysis. Recall from earlier in the year, hydrolysis, hydro meaning water, lysis meaning to cut. It literally means to cut by way of water. So this ATP is hydrolyzed and allows for the phosphate from this ATP group here to attach to the pump. Because of this action, what happens here, so long as we have 3 sodium ions that are inside the pump here, the pump will then change its shape. The shape will allow for the 3 sodium ions to be released into the outside of the cell, and it will be left open so that we have potassium ions that will embed into the potassium pump here, the sodium potassium pump. Now, once that phosphate detaches, it will allow the shape of the enzyme, the pump, to return to its original shape and will open up to the inside or the cytosol, allowing for the release of the potassium into the cell. Now again, this is all by way of against the concentration gradient. There is low concentrations of potassium inside, and so in order for us to get more potassium inside the cell, we need to use some form of method that gets it in there. This is working upstream. Now, I'll give you a little bit more information on why this is important to know why this process is happening in our cells, is that this is how our nerve cells function. What happens here is, think about this. If there are 3 sodium ions, you see 3 pluses. So you can imagine that the inside of the cell is putting 3 pluses into the outside, and then we're putting 2 pluses back into the inside. So what's happening here? Well, you're putting 3 out and 2 in, so therefore you're creating a difference of charges here. And what we're creating is essentially a quote-unquote battery here and an electrical difference. And you're not going to need to know this for the test, but I think it's important for you to understand for later down the road on why our cells are doing this. And they're doing it because it is going to create what's called an action potential, which is how your nerve cells communicate to the nerve endings. So again, the importance of this is in your nerve cells.